So what is alpha-lipoic acid? Alpha-lipoic acid was originally discovered in 1937. And it's a compound our body can produce. It's a very powerful sulfur-containing antioxidant, and generally it's derived from cysteine, the amino acid, which is sulfur-containing, and something called caprylic acid. So your mitochondria actually can, with these raw ingredients, can produce alpha-lipoic acid. And one of alpha-lipoic acid functions is that it's a very, very powerful antioxidant. Let's blow up this screen here and have a look. These two here are lipoic acid. And so you'll see in the center CoQ10, vitamin C, and then this substance here, 2-GSH, that's glutathione. So these are three very powerful antioxidants that help to regenerate tocopherol, which is otherwise sometimes known as vitamin E. Now, why are we talking about alpha-lipoic acid in regard to all this? Because one of the things that happens in your body is a natural process, is the formation of free radicals. Now, most of you have heard this term before, free radicals, and the counter to free radicals are antioxidants. So we need antioxidants to cancel out free radicals. Why? Free radicals do damage to our cells, can do damage to our DNA. So if the balance of free radicals outweighs the balance of antioxidants, we're in trouble and we're going to age a lot faster. Well, vitamin E right here plays a major role in helping to neutralize free radicals. So basically converting those free radicals into something less dangerous. And so in the process of vitamin E protecting you, you use CoQ10, vitamin C, and glutathione to regenerate vitamin E. So what happens, vitamin E becomes oxidized and we have to regenerate it to reutilize it. So these three nutrients basically recycle vitamin E. But what alpha-lipoic acid does is it regenerates vitamin C, CoQ10, and glutathione. So think of it as the master antioxidant regenerator. It's the battery that recharges your antioxidant system so that it continues to work for you, preventing the potential for all kinds of damage. Now, let's look at some of the functions of lipoic acid here, and what we're looking at are just generalized functions. So we know that it plays a role in glucose and fat metabolism or lipid metabolism. We know, as I've just spoken, it has an antioxidant effect. It regenerates antioxidants. It also has a reparation effect of oxidized proteins. So if you've got damaged proteins, that alpha-lipoic acid can help to repair those. We know it has anti-inflammatory effects and inhibition of something called NF-kappa B. And it also can chelate metals. So it's all some basic functions of lipoic acid. And as you can see here, just to generate energy, it's an antioxidant, an anti-inflammatory, helps with glucose uptake into cells. It aids in the metabolism of branched-chain amino acids. What are those? Those are very important amino acids that help to maintain your muscle. And so one of the things that happens, especially as we get older, we're exposed to more free radicals over time. We burn through more of our alpha-lipoic acid. We have less of it to help with the metabolism of branched-chain amino acids. One of the byproducts of aging oftentimes is something called sarcopenia, with accumulation of damage over time. Alpha-lipoic acid helps us maintain that through the metabolism of branched-chain amino acids, therefore being very important. And then, as I mentioned earlier, it preserves CoQ10. ALA possesses an excellent iron chelation property. It preferentially binds to zinc, lead, that's Pb is lead, and Cu, which is copper. Where might this be beneficial? If someone has potential lead toxicity or copper toxicity, you know, alpha-lipoic acid might be helpful in that regard. There are a number of animal studies and in vitro studies that show that alpha-lipoic acid can preserve neurological cells called hemochromatosis, which is an accumulation of iron in the tissues. It's genetic, and you might want to consider alpha-lipoic acid supplementation. as a result of, or as an effort to, try to bind or chelate some of that iron and prevent it from doing damage, because too much iron is in your attempt to protect yourself from free radical iron. So just keep that in mind. If you have acid, to try to kind of offset some of that potential damage, ask your doctor to monitor your zinc. Oxide-mediated endothelium-dependent vasodilation. Basically, that's Greek, but let's make it English. It helps your blood vessels dilate, therefore improving blood flow in the microcirculation, so getting more oxygen, getting more nutrients into the deep tissues, and especially this is supportive in patients with diabetic polyneuropathy, so those diabetics that have developed neuropathy as a result of poor blood flow, blood sugar, elevations in blood sugar, just like sugar makes the floor